section 5.2 is on verifying trigonometric identities. And on the notes, I gave you just kind of some tips that you can use when you're verifying. And now verifying is kind of like proving, if you ever took geometry and had to do proofs. But what we're doing here is we're algebraically verifying that an equation is true. Basically proving that it's an identity by using algebra. Okay, so my list of suggestions for you. The first one is to learn your fundamental identities from section 5.1. That's going to be your Pythagorean identities, your quotient identities, and your reciprocal identities. And then also, in addition to that, your even and odd identities. And that's on a handout that I have prepared for you. That's kind of a summary sheet that I'm going to show you a little bit later. So learn your fundamental identities. Step 2, simplify the more complicated side first. There will generally be a side that looks a little bit more complicated that you're going to work with to simplify first. Next, try rewriting in terms of sine or cosine. And number 4, use algebraic operations like factoring, multiplying the distributive property to find an expression that's easier to simplify. And then just the last tip is to remember that verifying identities is not the same thing as solving an equation. So for these problems, we're not trying to find the value of an angle. We're not trying to find, in most cases, the trig function value. We're just proving that that statement is true. And so the first example on the notes is a factoring problem. It just says to factor 4 tangent squared of theta plus tangent of theta minus 1. So when you look at this, you may not see automatically this is a trinomial. This would be exactly like if I told you to factor 4x squared plus x minus 3. If I gave you that and said factor it, you would be able to break it down into 2 polynomials. Same thing here, but our tangent is kind of acting as our variable. Okay, I guess the best thing for you is that on most of the homework in my math lab, these are multiple choice, or they've kind of filled out part of it for you. But just think about if you were factoring this polynomial, that in my first 2 positions, those 2 terms would have to multiply to equal 4 tangent squared. So I know I would have to have a tangent of theta here, so that when I multiplied them together, I would get tangent squared. Now, we have 2 sets of factors for 4 times 1 or 2 times 2. So we can try 4 and 1. I'm not going to write the 1 there. And then in our last positions, those 2 have to multiply to be negative 3. So I could have negative 3, positive 1, and then I have to multiply these factors together to decide if this will equal the original polynomial I started with. So when I multiply 4 tangent of theta times tangent of theta, that gives me 4 tangent squared. Then my outer would be 4 tangent of theta times 1, so that's going to be plus 4 tangent of theta. Inner would be negative 3 tangent of theta. And then last would be negative 3 times 1, so negative 3. My 2 middle terms would combine to be just tangent of theta, or 1 tangent of theta, which is the middle term I have in the problem. So this would be correct. So factoring, this is just kind of a little review, and factoring can be used if you want to simplify an expression sometimes. Okay, let's look at number 2. This is how most of your homework problems are going to look. It's going to say verify each identity. So I want to verify algebraically that the tangent of theta over the secant of theta is equal to the sine of theta. Okay, I can go back through my list of rules. It says, okay, start with a more complicated side. Definitely be this left side. try rewriting in terms of sine and cosine. Okay, I can rewrite tangent as sine over cosine, and I can also rewrite secant. If I remember, my reciprocal function or reciprocal identity would be 1 over the cosine of theta. Okay, I haven't changed the value of my problem. I've just substituted in equivalent values. Okay, so if I have a complicated fraction here, how can I reduce this? Okay, they both have the same denominator, and remember, if we want to write this out completely, this is the same thing as sine of theta over cosine theta times the reciprocal cosine theta over 1, and then what happens is our cosines divide out. Sine of theta over 1 is just sine of theta equal to sine of theta. So basically that's what we want to do. When we're verifying, we want to be able to take one side of this equation and algebraically break it down till it equals the other side of the equation. And so we have verified that this is a true identity if I can break down each side to be equal to the same function here.